So in question 2, we're given an integral here which we need to evaluate for 5 marks. So what we can do here is simply, well, calculate this. What I will do is firstly make a u substitution. I don't really want this 3x inside of the natural log, so I'll just sub in u is equal to 3x. Technically, we don't really have to do this, but it's going to feel a little bit easier to integrate by parts. Of course, we could just do it as it is already. There's no issue with that, but still, I feel like it will be a bit easier. So as usual, we just find these derivatives. From this, we see that dx is equal to 1 over 3 du. And so I can also change the limits. When x is equal to 1, u is equal to 3. When x is equal to 3, u is equal to 9. So the new integral after the u sub will just be from 3 to 9 of u over 3 squared times ln u times 1 over 3 du. And so if I multiply everything out here, I'll just have a 1 over 27 and then times the integral from 3 to 9 u squared ln u du. And well, as I said before here, now we're going to have to integrate by parts. So I like to use the di method. So I make a column for what I want to take the derivative of and what I want to integrate. No, the other way, because obviously I cannot integrate ln u, that's why we're doing this. I want to take the derivative of ln u, I want to integrate u squared. Derivative of ln u is simply 1 over u. And then the integral of u squared is simply 1 over 3 u cubed. And then I can cross multiply like this. And so this is just going to be 1 over, well, not really. So the solution will be 1 over 3 ln u times u cubed, and then minus the integral. So this goes from 3 to 9. We can already evaluate this. And then the integral of minus the integral of 1 over 3 u squared du, and this goes from 3 to 9 as well. And so this is just going to be, well, adding 1 to the power dividing by 3. So I'll bring everything together now. So 1 over 3 ln u cubed minus 1 over 9 u cubed, and this goes from 3 to 9. Right, and we don't really need the plus c here because we were plugging in limits, so the plus c would cancel out regardless. Okay, so now we can we'll start plugging in. So this will be the tedious parts, but we will do it regardless. And of course, let's not forget that there's a 1 over 27 multiplier in front of these both, like this, because that was over here and I just evaluated this integral, obviously. So if I start plugging in, I'll have 1 over 27 at the start, and then I will have a 1 over 3 times 9 cubed times ln 9 minus a 1 over 9 cubed, and then from this we subtract 1 over 3 times 3 cubed times ln u minus a 1 over 9 3 cubed. So that's the result. And now we just need to evaluate everything here. So this is going to be 1 over 27 Okay, I can so in the question we need to express everything as one logarithm. So okay, so here I forgot to plug in a 3. But right, we want everything in ln3 ideally, or at least that's what I think. That's going to be the smallest logarithm. So this ln9 we can just rewrite as 2 times ln3 because 9 is 3 squared and we can bring down the exponent. So this is just going to be 2 times 729 over 3, that's 9 cubed, times ln3 minus 81 minus 27 over 3, ln3 minus 3. Okay, and now that I have this, I can combine the ln3s. So 1 over 27, and then this is going to be, well, 2 times that. So that's going to be 486 ln3 minus 78, combining all of the constant terms, and then minus a 9 ln3 over here. Okay, and then this is just going to be a 1 over 27, 477 ln3 minus 78, like this. And then I just have to divide everything by 27. So this will just be 477 over 27 ln3 minus 26 over 9 if I simplify with a 3. And this is going to be the final solution.